G'day and welcome to the Off-Chain Podcast. Don here with you, and our guest today is Dr. Avi Loeb. He's the head of the Galileo project, founding director of Harvard University's Black Hole Initiative, director of the Institute for Theory and Computation at the Harvard-Smithsonian Center for Astrophysics, and the former chair of the astronomy department at Harvard University. He is the best-selling author of Extraterrestrial, The First Sign of Intelligent Life Beyond Earth, and a co-author of the textbook Life in the Cosmos, both published in 2021. His new book, Interstellar, is scheduled for publication next month, so pretty soon. He's one of the great thinkers of our time. He does not care what people think about him, as will be made plain in the interview today. He's just on the quest for the truth. So let's dive into part one of our interview with Dr. Avi Loeb. Avi, tell us about your origin story. How did you become a physicist? Tell us about that.
I was born on a farm and collected eggs every afternoon. Used to drive a tractor to the hills of the village and read philosophy books. And that shaped my career because I got connected to nature and less so than to people. I don't care how many likes I get on Twitter. I don't have any account on social media, but I would like to be educated by evidence, by experiments in which nature serves as the tutor. And the other thing that I realized at a young age was when I asked a difficult question at the dinner table, the adults in the room pretend that they know the answer and sort of invent something they can think of, or dismiss the question altogether if they don't have any clue. And that bothered me. And as a result, I decided to become a scientist so that I can get the answer myself. And that's pretty much representing my childhood curiosity, and I never gave up on it. I think it's really important to maintain a beginner's mind, in the words of Zen Buddhism, so that we can absorb what nature teaches us. I mean, a century ago, physicists discovered quantum mechanics. We still don't fully understand it, but it's the basis for all the gadgets that we use, electronics, internet, and so forth. And nobody would have expected quantum mechanics to describe reality. So we should be humble and serve as students of nature rather than showing off, doing mathematical gymnastics and thinking about ideas like the multiverse, string theory, extra dimensions that cannot be tested in our lifetime.
All right, so curiosity basically is one of the things, and the lack of ready-made or at least available answers to you, that's what kind of helped your curiosity kind of burn and sent you down that scientific path. What today does an average day look like for you as a physicist? What does that look like?
I wake up early at around 4:30, 5 a.m. before sunrise to check a few emails, and then I jog in the company of birds, ducks, bunnies, wild turkeys. I really love nature, and irrespective of whether it rains or snows, I just go out, and every day looks different. The sunrise looks different, and that's very refreshing to me. As I come back home, I have breakfast, and then I have some creative ideas to write about, either in the form of an essay in Medium. I usually, every couple of days, I put an essay there, and I have a large community of followers on that, or a scientific paper that I'm working on. And in both cases, it must represent some new idea. I don't enjoy mentioning nuances on what we already know. Just like a child, I would like to learn more about the world surrounding us. And it's not so much about bragging concerning what we already know. Experts develop their self-esteem based on past knowledge, and I resist that because what's exciting in life, we live for such a short time, is to explore the unknown. And when you explore the unknown, you take risks because you don't know what's right. And Albert Einstein made 3 mistakes between 1935 and 1940. He argued that gravitational waves do not exist. He argued that black holes do not exist. And he also argued that quantum mechanics doesn't have spooky action at a distance. And guess what? Over the past 6 years, He made these mistakes in 5 years, but over the past 6 years, and the Nobel Prize was awarded to 3 groups of people who showed experimentally that Einstein was wrong. Gravitational waves were detected, black holes were discovered experimentally, and quantum mechanics was found to have spooky action at a distance experimentally. This is called entanglement. And so it's clear that Einstein made mistakes, but that's part of working at the frontiers. If you don't make predictions that can be tested, you're not doing something interesting.
Yeah, absolutely. What are the things that are interesting you at the moment? When I think about you, I'm thinking about black holes. I'm thinking about Big Bang. I'm thinking about space generally. I'm thinking about alien life and the search for it. I see the Galileo project in your background there. I've heard it said of you that you are the modern day Galileo also. What's interesting the modern day Galileo today?
Well, the titles are not so much of interest to me. The messenger is not important. What's important is the message. And the Nobel laureate in physics, Steve Weinberg, he studied the universe for many years. He wrote this book, The First 3 Minutes. And towards the end of the book, he says, the more the universe appears comprehensible to us, the more pointless it looks. And I sort of figured out why it looks pointless to cosmologists, and I was one of them, because cosmologists focus on lifeless objects, elementary particles, stars, galaxies, dark matter. These are entities that have no life in them. These are dead objects. And of course, we know from our private lives that once we find a partner, we get a whole new meaning to our life. And so what we are missing in the study of the universe is finding a sentient partner, another civilization that may have developed technologies perhaps far superior to what we have somewhere else. And, we can always argue that we are the smartest species that ever existed since the Big Bang 13.8 billion years ago, and therefore stay at home and just look down on the surface of this rock that we were born on, the Earth. But this is equivalent to singles arguing that there is no partner for them to find, and therefore they don't engage in any date. Obviously, they'll remain single. It's a self-fulfilling prophecy, but they're missing. They're missing something important outside of their home. And so what I'm recommending is for us to get engaged with our environment, the cosmic neighborhood that we live in, and go out to dating sites and try and find other civilizations. Now, most of them may not exist anymore. They might have died, just like most people, died by now. But we can find relics of them. So the approach is similar to going to your backyard, and most of the time you find the rocks that you are familiar with. But every now and then you might find a tennis ball that was thrown by a neighbor. And that tells you that the street has different objects than the ones you find in your backyard. And indeed, out of the 4 interstellar objects that we know about, these are objects that came from outside the solar system. They were just discovered over the past decade. We didn't have the instruments to detect them before. Out of the 4 of them, 3 look weird, unlike the rocks that we had found in the solar system before. So I say, that's intriguing. Let's continue looking. Let's get more evidence. While my colleagues say, oh no, these are just rocks. They are rocks of a type that we've never seen before, but they are still rocks. And in fact, maybe one of them is a comet, Oumuamua, we can talk about it, is a comet, but its cometary tail is invisible. And to me, that reminds of the story of Hans Christian Andersen, where the kid was saying the emperor has no clothes. And the adults were saying, no, these are beautiful clothes, they are just invisible. And in this case, the emperor is this object, Oumuamua, which was the first reported from outside the solar system. And my colleagues are saying it's a comet. We just can't see the cometary tail. And I say, well, if there is no cometary tail, it cannot be a comet. It may be artificial in origin. So I feel like this kid, and I'm very proud to be the kid who plays it honest. So to me, the most important question for the future of humanity is whether we are alone, and if not, what can we learn from them? Because as far as I remember, with my daughters, when they were young, they were at home, they thought that I was the smartest, the world centers on them, just like humanity did. And then when we brought them to the kindergarten and they saw a smarter kid on the block, of course, they had a psychological shock. But we have to understand the reality that we live in because we need to adapt to it. And whether we deny it or not, it's out there. Just like the Earth moves around the sun, and Galileo was put in house arrest because the clergy back then denied it, and they worried about political implications. But that didn't change the fact that the Earth moves around us. It's not the messenger, it's the reality that we live in that we need to pay attention to. So that's the most important question that I would like to answer. Who predated us? Because it's clear that most stars formed billions of years before the sun, and a substantial fraction of them, somewhere between 3% to 100% of the sun-like stars, have a planet the size of the Earth, roughly at the same separation. So clearly, other civilizations could have existed billions of years ago, and they could have sent probes in our direction because it takes less than 500 million years for a spacecraft of the type that we sent, made of rockets and chemical propellants. It takes 500 million years to cross the entire galaxy. So there was plenty of time for them to reach us. And even if they're dead by now, they're not around, we could still find the packages that they sent to our mailbox. And all we did in the past 70 years was search for radio signals, which is like waiting at home for a phone call. If nobody is calling you at the time that you're listening, you will not hear anything. If anyone sent us a radio signal, a billion years ago, it's a billion light years away. We will never hear it. However, these packages, these spacecraft, move at a speed that is bound by gravity to the Milky Way galaxy. So they should be around still. And that's a completely different method of search. So that's my most important priority right now. But as you said, I worked on black holes. I worked on the early universe earlier in my career. And there are important questions about those. For example, what happens in the middle of a black hole? A black hole is an extreme structure of space and time. It's the ultimate prison. You can check in, but you can never check out of a black hole. There is this boundary called the event horizon. The interesting question is what happens to matter that falls into the event horizon? Where does it end up? And I came to think about this question because I had a flood in my basement one day, and the plumber came in and we looked down and the pipe, and we realized there are tree roots blocking the flow of water out of the house. And then I realized, okay, so what really happens near the singularity of a black hole, near the center of a black hole, where Einstein's theory of gravity breaks down because the curvature of space and time diverges, becomes infinite. And we know why it breaks down, because Einstein's theory does not incorporate quantum mechanics, which is essential for describing small scales. So the question is, what really happens if you had a theory of quantum gravity that is predicting anything? What would it predict for the fate of the matter? And one possibility is, of course, that just like my clogged sewer, the matter, like the water in my basement, will collect into an object near the center. And so that's an open question, and that would be my favorite solution, that there is a very dense object in the center of a black hole. We don't know what happens there. And then another question related to the universe, of course, is it's quite similar because there is a singularity in time. When you go back in time, there is the Big Bang, because the universe expands, and if you go back in time, you end up in an infinite density of matter. And that's the point in time of the Big Bang, 13.8 billion years ago. And we can't tell what was there before the Big Bang because, again, Einstein's theory breaks down and we don't have a predictive theory of quantum gravity. So I would like to know what happened before the Big Bang. And one fun idea that I had was that if a civilization that is far more advanced than we are, we had only 100 years of science and technology. So imagine a civilization that had the benefit of 1,000,000 years of science and technology, or 1,000,000,000 years. In principle, if they have a theory of quantum gravity, they could understand how to create a baby universe in the laboratory. And perhaps our universe was created by some intelligent beings in lab suits.
Right. So this basically is one of the things when I'm thinking about how people are explaining the origins of existence, or the origins of not just life, but matter and time and space and etc. One of the kind of problems people tend to get to is you come down to either a necessary being like a god, and so that's kind of the end of discussion, because you say, well, who made God? God doesn't need a creator; he's God, or it is God. Or you get a different kind of creator, which are some other kinds of sentient beings, or aliens from some other place, or multiverse, but from my perspective, that really just kicks the can down the road, because where did they come from, and then where did they come from, until you get to, again, either a necessary being or a giant question mark. Do you have a favorite answer to that question?
Yeah. So there is an interesting way of bringing religion and science together. Because if you look at religious texts, God is assigned abilities that are superhuman, creating a universe, creating life, and so forth. But with science, in principle, we can get to a point, or another civilization got to a point, where it's capable of doing these things. If it knows how to engineer quantum gravity, it may create a baby universe. If it understands biology extremely well, it can create life. We are almost creating life in our laboratories. So a very advanced scientific civilization is a good approximation to God. And of course, the one beautiful thing about it is that if we find it, if we encounter it, it will be in the reality that we all share. Just like we see the sun, we see the moon, we will encounter a civilization capable of doing that were actions that were assigned in the past to a divine entity. So that could be part of our reality, as long as we open our mind and our telescopes to that possibility. But with respect to your question about the history of the universe, one possibility related to the scenario that I mentioned is that an advanced technological civilization would create a baby universe similar to ours, in which a new civilization will form and create another baby universe, and so forth forever. Just like in biology, you have one generation giving birth to the next generation, to babies, and the babies mature and become adults, and then give birth to new babies, and that can go forever. So that could be one way to resolve the puzzle, but of course there could be other ways.
Yeah, for sure. How does that then differ from a simulation, for example? And how would we know? Because aren't we already doing this kind of thing with pursuing a metaverse, or building AI and those kinds of things? Isn't the natural end of that? How would AI in a metaverse, if they were created with specific parameters, know that they are in a simulation, or a simulation or a sentient being in a simulation? Is that not a reasonable answer to this question?
No, it's not, because I distinguish between the reality that we all share and a reality that you enter by putting goggles on your head, which is the metaverse, or a reality that you enter by taking recreational drugs, which is a different reality, but it's subjective to your experience. And that is not the physical reality that we all share. Physics is all about figuring out the reality that we all share. And of course, you can imagine things, but those would be in your imagination. You can simulate things, you can let AI build things on the internet, but that is not equivalent to the reality that we all share. When I talk about that physical reality, is what I encounter when I jog out in nature, when I see nature, when I do experiments, when we look at the sky and see stars and galaxies. As far as I can tell, these are not a simulation. These are real objects that we are witnessing. And of course, the fact that the Earth moves around the sun was verified by sending the Orion spacecraft a few months ago that took a picture of this blue marble from a distance, and you can tell that it's moving around the sun. So that's the reality that we all share. Now, you may argue, well, maybe there are goggles on our head and we feel that this is the reality, but it's not really the reality. Well, to me, that's, this is just intellectual gymnastics, okay? Because if someone is not able to tell the difference between a simulation on the computer or goggles showing you the metaverse and the actual reality, then, so be it. That person, I wish the best to that person. But I do see a difference between reality, the way we all witness it, and the simulated reality, which has pixels in it. But
so
just
I might have misunderstood.
Yeah.
If I kind of communicated what I was getting at, what I mean is not that there are these potential creators who have made what we experience as reality, who are coming into this reality, and then as if they are using a VR goggle or those kinds of things. But I mean, if we make a computer simulation and we create, say, we have the power to create sentient beings within the simulation, they couldn't necessarily know that they are in that simulation because given the parameters that you're talking about with these people who are in the previous iteration of universe, or they're the ones making this universe, is that how does that distinguish from a computer simulation?
Right. So the distinction is, of course, between a thought experiment and a real experiment that is appealing to all our senses. And you might say, well, everything is processed through the brain. So in principle, if you take the brain and fool it, if you give it drugs, it will imagine things that do not exist. If you put goggles on the head, it might imagine things. But that would be specific to the brain that you provide these ingredients to. But if you let everyone witness the physical reality that we all share, they would witness the same reality. And I think that is a big difference. I don't think we live in a simulation, if you ask me. Of course, people that have enough money not to worry about their bank account, not to worry about how politicians affect their real life and their families. And, you can imagine that you are living in a simulation. I don't belong to that camp. I have a clear distinction between the reality that we're trying to learn from, that physicists are trying to understand, and what people construct in their computer algorithms. That's a very different thing. And the risk from mixing the two is that you have for 50 years a whole community of theoretical physicists working on ideas that cannot be tested and developing a culture where tests are not really necessary. And that, I think, is not only harmful to society the way that recreational drugs are, but it's also dangerous for the progress of science, because if we are not humble enough to let nature educate us through experiments, we will not learn new things. And I can give you an example. There was a very senior physicist who gave a lecture, a colloquium, on what is called the swampland landscape in string theory, and made some predictions about the universe. So I approached him after the lecture and asked, that is great. So now if we observe the cosmic microwave background, the radiation left over from the Big Bang, which has tiny fluctuations in its temperature, and it looks as if the predictions that you mentioned are violated based on the data that we collect, would that rule out string theory? And he said, no, it will only rule out my conjecture about the landscape of string theory. String theory must always be right. Now, this is what I call the risk of mixing virtual reality with the actual reality, because once you live long enough in a virtual reality, you start thinking, oh, there is nothing else. And that is dangerous for a physicist, because I think we should always allow the guillotine of experiments to chop the head of ideas that are not representing the actual reality that we all share. Otherwise, we will never adapt to it. One solution to Fermi's paradox, Fermi, about 70 years ago, had lunch in Los Alamos. They discussed extraterrestrials, and they agreed that it's very likely that there is someone else out there. And then Fermi said, Enrico Fermi, a very famous Nobel laureate physicist, he asked, where is everybody? And, one possible solution would be to say, well, they got addicted to their virtual realities. They're not communicating with anyone. They're just putting goggles in their head, sitting in their homes and just imagining something, or maybe they're high on drugs or whatever. That would be a civilization that reached a point of no communication whatsoever, no progress whatsoever, because they're not engaged with their actual reality, the environment that surrounds them.
Yeah, sounds like the storyline from that movie WALL-E, where we did actually achieve, as a humankind, some sort of intergalactic travel, but it was all very unfit people in front of screens.
I should tell you that my dream, so you obviously know that Elon Musk dreams of dying on Mars. My dream is quite different. I dream of going to space, perhaps with Musk's one of his rockets, and then I really hope something will fail so that my body will be floating in space, and I will probably die soon afterwards, but it doesn't really matter for the storyline. And my hope is that later Jupiter will kick me out of the solar system gravitationally, and then I will be floating in interstellar space for 1 billion years, until I collide with a habitable exoplanet, a planet similar to Earth, around the star similar to the sun. And then my body will go through the atmosphere of this planet at a high speed and will burn up like a meteor. And my hope is that there would be a curious scientist out there who would say, what is this interstellar meteor? It looks different than the space rocks that we found in our planetary system for a while. And then this curious scientist will go to the ocean and try to find the relics of this meteor and then put them on exhibit in a museum. And that would be my greatest honor for my fragments to be displayed in an exhibit to an extraterrestrial intelligent civilization.
Yeah, that's quite a dream. I should say also, I also don't believe that we are living in a simulation. But now we're talking about extraterrestrial civilizations. I mean, if we can answer Fermi, why haven't we seen them? When you consider, like you said, even from our world, from Earth's perspective, we've had perhaps 100 years, like a century, in a very long history of the Earth's existence, to be able to actually detect, even think about the possibility of there being extraterrestrial life, given the fact that there may be billions of opportunities for life to have existed, sentient life less so, and sentient life that's looking for other life perhaps less so, and all of that exists in the same time that we happen to be able to find those. How do you rate the possibility of, not just in our lifetime, but over the next 10,000 years, let's say, discovering other sentient life somewhere else?
Oh, I think it's very likely not in 10,000 years. I think in the next few years, perhaps, because the one thing to realize is that Enrico Fermi was just sitting at the lunch table and asking this question in Los Alamos over a period of a few hours and of a conversation. And that's a very small fraction of the age of the Earth or the universe in total. So if you sit at home on the sofa and you say, well, I don't see any neighbors around me, well, that means that you were too lazy because you didn't even check the windows and didn't use telescopes to look for your neighbors. And the amazing thing is that only over the past decade, 10 years, we had the instrumentation that allows us to discover objects from outside the solar system. The first one was a telescope, a survey telescope in Hawaii that was constructed to find near-Earth objects because the US Congress tasked NASA to find 90% of all the objects bigger than a football field that may collide with Earth. These are called near-Earth objects. And of course, we know that dinosaurs were killed 66 million years ago by a rock the size of Manhattan Island that collided with Earth. So we are smarter than the dinosaurs. Our brain is more important for survival than this huge body that the dinosaurs had. So we look up with our telescopes and try to search for objects. And that's why the Pan-STARRS telescope was constructed around a decade ago. And as a result, we discovered the first object the size of a football field based on the reflection of sunlight that came from outside the solar system. And it didn't look like a comet. It didn't look like an asteroid familiar to us in the solar system. We can get into more details. And then together with my student, Amir Siraj, we discovered the first two interstellar meteors. These were roughly a meter in size. And these are objects that collided with Earth and exploded in the Earth atmosphere and generated a fireball that allowed us to detect them. So these were the first three interstellar objects, and the meteors were tougher than all other space rocks ever detected. And that makes these interstellar meteors unusual, weird, in terms of their material composition. And so my reply to Fermi is, we just started the search, and 3 out of 4, I mean, the fourth one was a comet called Borisov, 3 out of 4 interstellar objects appear to be weird. So we should get more evidence because perhaps there are technological objects, either space trash or functional, that are passing in our neighborhood. And only recently we've been able to detect them, only over the past decade. And for 70 years, we've been searching for radio signals. And as I said, that's just like waiting for a phone call at home. It's not the right approach. So it's quite possible that the reason we haven't found anything is because we haven't looked. And, in the words of Robert Frost, the poet, he said that he took the road not taken. And that is the road I enjoy taking because there is a chance for finding low-hanging fruit in the coming years. So my hope is you don't need to wait tens of thousands of years. I mean, for tens of thousands of years, we haven't really looked and searched. And so we should just be open-minded about it and see what we find, what comes into our backyard from the cosmic street, so to speak, from outside the solar system. But if you... more generally, I would say there is also the issue of longevity of the civilization, because within 1 billion years, the sun will burn up all the oceans on Earth. It will become warmer, and then the greenhouse effect will make our oceans boil off. So we only have 1 billion years left, irrespective of how well we behave in terms of climate change and so forth. And simply because our star will get hotter. And most other stars, like the sun, formed billions of years before the sun. So in fact, they boiled off their habitable Earth-like planets a long time ago. And there might have been cries for help. That must have been the most important topic in the news for those civilizations that were next to a star about to boil off all water on their surface. And so they must have cried for help, but we were not around to listen to those cries. I would argue that the best chance to listen is to cry from a civilization that is about to lose its life, because the star is evolving and making the planet inhospitable to life. And so many of these past civilizations may have died by now, and that's why we can't communicate with them. Perhaps they stopped using radio communication because that's a very primitive approach that we developed early on. And so it's really all about the method that you're using and the recognition that we are dealing with a long expanse of space and time. We're talking about billions of years for the units of time in the universe. And that's a billion years is 10 million times longer than our lifespan. So it's really impatient of us to imagine that during our lifetime we will witness something that is beyond any reasonable doubt. And the second is the huge space that surrounds us. It takes a long time to travel. It takes a billion years to cross the Milky Way galaxy with chemical rockets. So just being in Los Alamos and asking this question over lunch is not really a serious professional approach to the matter, and we should do better.
Yeah, awesome. Yeah, man. So when we're thinking about, say, those 3 out of 4 interstellar objects that look weird, do they look weird, in your opinion, because we don't understand them? Or obviously the hope is that they look weird because they're not natural or naturally forming. What is the chance that they look weird because we just don't understand, say, the physics of it or the materiality of it? Is it just, do we need more humility in our approach rather than thinking we've arrived at a kind of appropriate level of humility in regards to these things?
Well, I would give equal weight to the 2 possibilities that you mentioned. I would say either these first 3 interstellar objects originated from a system that is very different from the solar system, which is a possibility that they are natural, but of a source that is quite different than our backyard, okay? That is a definite possibility. But at the same time, we should also allow for the possibility that they were manufactured by a technological civilization elsewhere. Now, to examine these possibilities, we should ask what kind of properties should the object have to explain the anomalies that it exhibited. For example, Oumuamua was tumbling every 8 hours. The amount of sunlight reflected from it changed by a factor of 10, and that meant that it has a very extreme shape, at least 10 times longer than it is wide when projected on the sky. And moreover, the best fit to the variation of light was that of a flat object, disc-like. And then it was pushed away from the sun by some mysterious force, non-gravitational, and it didn't show any evaporation of gases from it. The Spitzer Space Telescope looked very deeply and couldn't find any traces of carbon-based molecules or dust around it. So then if you want to explain it, this acceleration, non-gravitational acceleration, from a natural origin, that was attempted over the past few years by mainstream astronomers. So what are the possibilities that were suggested? One is that it's a dust bunny, a collection of dust particles very loosely bound in a cloud that is 100 times less dense than air. And the problem with that, in my view, is when such an object that is so fluffy, I mean, the idea is that it's so fluffy that it can get pushed by reflecting sunlight. And the problem with it is that as it gets close to the sun, it will be heated to hundreds of degrees, and then it will not maintain its integrity. This is not a solid body. This is a very fluffy object. And so other people suggested, well, maybe it's a hydrogen iceberg, a chunk of frozen hydrogen. So when it evaporates, it's actually a comet, but we can't see the cometary tail because hydrogen is transparent. And the problem with that, as we showed in a paper, is that it will evaporate very quickly during its journey through interstellar space. So it cannot survive the journey from molecular clouds that make such objects. We've never seen a hydrogen iceberg, and the only place that it could form is in a molecular cloud that is mostly made of hydrogen, not in a planetary system like the solar system, but it wouldn't survive the journey. And the authors of that paper agreed with us. And then another suggestion that was made was maybe it's a nitrogen iceberg, a chunk of frozen nitrogen that was chipped off the surface of a planet like Pluto. And the problem is, we wrote it in a paper again, there is just not enough solid nitrogen in the Milky Way galaxy. If you account all the solid nitrogen that you might have on the surface of Pluto's and you chip all of it, you just don't get a large enough population of chips that would explain the discovery of Oumuamua. And then, most recently, just a week ago, there was a paper in Nature suggesting that Oumuamua was actually a water iceberg, the regular type of comet, but it was exposed along its journey to cosmic rays that broke off the molecules of water into their constituent hydrogen and oxygen. So if a third of all the water molecules would break up, this paper argued once the object comes close to the sun, the hydrogen would evaporate, leaving the water and oxygen behind and giving the object the kick that was observed. The problem with that, as we showed the day after the Nature paper appeared, is that the authors made a mistake. They balanced the heat input from the sun by radiation from the surface of the object. So they got a temperature of the order of 100 to 200 degrees above absolute zero. But what they forgot is to include also the energy needed to separate the hydrogen atoms from the lattice. And when you include that, you end up with a cooling term that is 1,000,000 times bigger than the terms that they used. They just forgot about this cooling term. And when you include it, you find that the surface temperature drops by an order of magnitude, and then this model is not viable. So these are the challenges of the natural origins that were proposed.
So that's it's hard to we won't be able to actually take an expedition to go and suss out that particular interstellar object, but I believe you're planning an expedition to go and see an interstellar object that's landed on the Earth. Can you tell us a little bit about that?
Sure.
And what you're hoping to achieve there?
Yeah, with respect to objects like Oumuamua that pass near Earth, our hope is to date the next Oumuamua. I mean, it's just like going on a date and realizing that the partner was very interesting, but that person already left through the door and you can't really find it again. So what we are trying to do is find the person similar to it. And the same here. So we have a dating app. It's called the Vera Rubin Observatory in Chile. And it will start operations in a year and will have a camera of 3.2 billion pixels, 1,000 times more than you have in your cell phone. And the hope is that it will find more objects like Oumuamua. And most of the time, we might find a comet or an asteroid that are familiar, and we will swipe to the left. But every now and then, we might find a weird object, and the goal would be to take much more data on it. For example, with the Webb telescope, observing it 1,000,000 miles away from Earth, together with a telescope on Earth, will allow us to see the same object from two directions. And just like having a pair of eyes, and then we can pinpoint very precisely the trajectory of the object in 3 dimensions and infer whether it has any propulsion separate from the sun's gravity. And that would be a very interesting thing to explore in the coming years. But coming back to your question about the interstellar meteor. So the first interstellar meteor, it was detected by US government sensors. And when we submitted our paper for publication with my student, arguing that it's interstellar in origin based on its high speed. In fact, outside the solar system, it was moving faster than 95% of all stars, which makes it quite remarkable. But initially, the paper was not published because the argument was, we don't believe the US government. And then the US Space Command wrote a letter to NASA that confirmed that the 99.999% the interstellar origin of this meteor. So as soon as they released that letter, our paper was accepted for publication. And the US government also released data about the fireball of this meteor that was discovered on January 8th, 2014. That allowed us to infer that it was the toughest among 273 other meteors in the same catalog of NASA. And so that makes its material strength at least 10 times larger than all other space rocks, 272 of them in the catalog. So that is raising the interesting question. Was it, as you said before, did it come from a natural source, like perhaps an exploding star, a collision of two neutron stars, or something unusual, different from the solar system? Or was it artificial in origin, made of an artificial alloy like stainless steel? And there is a simple way to settle that by finding relics from this meteor and studying their composition. And that's what we plan to do. So it exploded about 10 kilometers above the ocean surface, of the order of 100 kilometers off the coast of Papua New Guinea in the Pacific Ocean. And we are planning an expedition to collect the fragments that may have been left behind. And we were able to localize the site of the meteor to within a kilometer, thanks to excellent seismometer data on Manus Island in Papua New Guinea. And so we modeled the data and we were able to get a very precise localization of this meteor site. And we are going there, and hopefully within a few months, we'll know what it is made of. And of course, it's challenging to find small fragments at the bottom of the ocean, but I hope, without searching, obviously, we will not find anything.
That sounds amazing. What's the greatest hope for you in terms of this expedition?
Oh, I told the curator of the Museum of Modern Art in New York City that if we find any gadget, I will put it on display because that would represent modernity for us. And I got an email from someone who heard that, and it was on a Zoom call. And that someone said, please don't press any button because it would affect all of us. And I said, don't worry, I was just joking, and frankly, I don't expect any big piece of material because this explosion released a few percent of the atomic energy output of the Hiroshima bomb. Obviously anything in it melted into small pieces, and these droplets just rained down as hot rain shortly afterwards and sank to the bottom of the ocean. We are hoping to find some of them.
All right, so very difficult. Even in the difficulty, it is at the difficult end of the difficult spectrum. That's what I'm hearing.
Yeah, but life is worth living just because of the challenges that we can face. And it's really, the reward is new knowledge. That's the biggest reward that I can imagine, waking up every morning, that I will learn something new today. And it really doesn't matter what we already know. It really matters that we learn more.
So is that the answer to, my next question was going to be, why space? So why now? If, for example, we're not going to discover our cosmic neighbors anytime soon in the next 1,000 years, 10,000 years, in a meaningful, interactive kind of way, what's the answer to the why question for why look to the stars? Why consider space? What are some of the tangible, like today, impacts? Obviously, if we discover aliens, that's a massive tangible impact. But what about for the regular person on the street? How does looking to the stars and how does, going off the coast of PNG potentially impact their lives?
Well, it will have a huge impact on the future of humanity because, we could potentially find two types of objects, either space trash. These are objects that are not functional anymore, just like Voyager would be in 1 billion years. So we sent it to interstellar space and it will not be functional anymore, but it could appear as a meteor if it collides with an exoplanet. And the other type is, of course, functional devices. And those would be much more informative for us because they would serve as the shadows of the senders. And I mean shadows in the context of Plato's allegory of the cave. As you know, the allegory was that prisoners are chained to the ground in a cave. That was Plato's allegory for humans. And they were seeing shadows from things behind them. There was some fire lit behind them, and it casts shadows from objects that they cannot really see. And Plato used it as an allegory to our life. And the way I think of it, if we find extraterrestrial technological equipment that is functioning, is that we will see the shadows of those who sent them. We are chained to Earth. This is our cave, so to speak. We are chained to it by gravity. And we spend our life on Earth, on the surface of this rock. But if we do find some equipment that originated from a sender, a sentient sender, and it's functional, it may give us hints about what this sender is about. Because, in the Old Testament, actually the first chapter of the Bible, it says that God created mankind in its image. And what did mankind create? We created artificial intelligence in our image. Right now, GPT-4 is getting really close to human intelligence. And the reason is that it has about 100 trillion connections, and the human brain has 600 trillion synapses. So in terms of numbers, our AI, the most sophisticated AI system, GPT-4, is getting really close to the human brain. And that's why many people argue that we are at the threshold of sentient AI. And if we are approaching this threshold about a century after developing our modern science and technology, other civilizations would have reached it a long time ago. And therefore, if we see a functioning device, it will likely be equipped with AI. And the reason is simple. There is no opportunity to wait for guidance from the senders. You must have an autonomous system, because the light travel time, the time it takes a signal of communication to travel between the sender and the gadget, is very long. I mean, even the nearest star is 4 light years away from us. And, the farthest stars are 100,000 light years away, so in the Milky Way galaxy. So there is no way that a gadget would wait for guidance from the sender very far away. And AI offers a solution, because it can have machine learning that learns from experience. It will be autonomous, and it will follow the guidelines of the sender. And so if we ever find functional AI astronauts from other civilizations, we could potentially imagine that they are in the image of the sender. We will not encounter the sender, but it will give us a sense of what the sender is like, and perhaps we'll need to use our AI systems to interpret their AI systems. And our AI systems might have kinship to their AI systems. Alan Turing, about a century ago, he invented the idea of the imitation game, and that's called the Turing test, for gauging whether an AI system is capable of imitating human intelligence. So that's called the imitation game. And the way I think of the imitation game is when our AI systems will try to imitate extraterrestrial AI systems that are far more advanced than they are. So it's a different twist on Turing's imitation game, in this case, in the extraterrestrial context.
Yeah, okay. So it strikes me that I actually haven't heard that take before, an AI astronaut. That actually sounds pretty awesome. It strikes me, though, that, you go back 70 years, our perspective or our collective imagination about aliens, let's say, basically matched our understanding of technology at the time, how we would imagine it in the future. And even now, as we're talking, it basically matches our understanding of our technology at our present time, plus a couple of years into the future. I'm just wondering, if we meet them, would we even notice them?
Well, that's an excellent question. But the one important aspect of, for example, the Galileo project that I'm leading, that I established a year and a half ago, is, in order to find those objects, first of all, you need to exclude what is familiar to us. And that implies natural objects like birds in the sky or meteors made of rock, to distinguish them from human-made objects like drones or balloons like the ones shut down by the US government not long ago. And once you exclude a natural terrestrial origin or human-made origin, then you can start pondering on what it means. I mean, what are these potentially extraterrestrial objects in case they move in ways that our technologies cannot reproduce? Or if you have a high resolution of an object like that, it may show screws and bolts, so it's clearly not a biological object. And also you might notice a label saying made on an exoplanet. That's a possibility. And so if we do recognize that, then the next question is the difficult one, the one that you asked. What does it really mean? Can we understand the purpose of this thing? What is it seeking? And that may take us a while. And as you say, we may not be intelligent enough to figure it out, but it would be fun to try. It's just like breaking the enigma, the way that Alan Turing broke it with his computer system. We can try to use our best AI systems to figure it out. And I'm not sure we will be successful, but it's an opportunity for us to learn about technologies that we don't possess and things that we are not familiar to us. And my point is, if a cave dweller finds a cell phone, the cave dweller would argue, oh, this is a rock of a type that I've never seen before. Sounds familiar? And then, of course, if the cave dweller has a kid, the kid might be more curious and say, give me that thing, and start pressing some buttons on it and realizing that it's not a rock. Okay, I'm trying to be that kid. I'm saying, let's collect more evidence. And, it's not easy in the sense that there is no federal funding to this research as of now, because those committees that allocate funding for research, they say, we don't want to waste taxpayers' money on a risky proposition. And I say, well, why don't you ask the taxpayers what they're really interested in? And they will tell you that they are more interested in this subject than in the nature of dark matter, most of the matter in the universe. And you know what? There was an idea of what the dark matter is, that it's representing some new symmetry of nature, supersymmetry. And that was the most popular idea when I started doing astrophysics 35 years ago. And then we built the Large Hadron Collider, a collider that smashes particles at the highest possible energies. These are protons, in trying to produce the particles that represent the dark matter based on supersymmetry in the natural range of parameters that everyone predicted. And we invested $10 billion in that facility. And we haven't found anything. Okay, so when people say extraordinary claims require extraordinary evidence, I ask them, well, wasn't supersymmetry an extraordinary claim? And nevertheless, we put money towards exploring it, and then we tested it, and we found it to be wrong in the natural range of parameters that were proposed. So that's the way science makes progress, because if you just argue extraordinary claims require extraordinary evidence and you don't fund the search, then it's a circular argument. It's a self-fulfilling prophecy. You will never get extraordinary evidence if you're not seeking the evidence. So my motto, my aphorism is extraordinary evidence requires extraordinary funding. And I'm trying to break this mold of not seeking the evidence through the Galileo project. We are privately funded by private donations. People that came to the porch of my home after they read my book Extraterrestrial and were very inspired by the vision. And my next book is actually Interstellar, to come out in August 2023. And it talks about the implications for the future of humanity, of finding a partner.
So, I mean, that's what this podcast is about the future and how to be a part of it, how to participate in it, how to help shape it. What does it look like in terms of funding? are there other ways that individuals or even entrepreneurs or physicists can be involved in the kinds of things that you are doing at the moment? And what are some of the returns on that investment other than a future hope for an answer to a question that you're still coming up with?
Well, I think it's a question that if we find the answer to, it will be the most important discovery that science ever made. So intellectually, it's extremely important, even more than discovering that the Earth moves around the sun, because if we find evidence for a technological civilization out there, potentially we can also learn what kind of technologies it's using. And for entrepreneurs, that could be a way of making money by importing these technologies to Earth. And it's a way of looking at our future, because others may have gone through our future before us. And if we just study what they produced, we can sort of imagine better what we should aspire to. That's my hope, actually. And, if you look at human history, it was all the atrocities were shaped by a group of people trying to feel superior relative to other people. And that's unfortunate, because my hope is that if we realize that there is an intelligent civilization out there far better than we are, then we would realize that we should treat each other as equal members of the human species, because they are so much better than we are. So we better get our act together. And, as of now, we are spending $2 trillion every year on military budgets worldwide. And I calculated that if we were to listen to John Lennon's words, imagine all the people living in peace. Suppose we took it seriously, okay? And we imagined all the people living in peace. Then we would have a surplus of $2 trillion a year. And suppose we decided to allocate it to space exploration. Then it turns out that we can send a CubeSat, a probe, to every star in the Milky Way galaxy, tens of billions of them, within a few decades. So just think about it. A civilization like ours, with the same resources, that decides to be peaceful rather than killing each other, could send a probe to every star, including the sun, within a century of its technological evolution. And what that means is that we can be hopeful that they did that. And if we find that evidence, we could learn from them. And that's my real hope.
Yeah, okay. So, that brings up a bunch of other questions for me. For example, if, you brought up human history. In the history of humanity, it seems like the lasting peace tends to come through an overwhelming and crushing military victory. And so if we hope for a different future for us as humans, even as we're looking to space and looking to the stars, as we've been speaking about today, who will get to decide? Say, for example, we do come across a relic of alien technology, of a long gone, a billion years ago gone civilization. Who gets to use that? Who gets to decide who owns Mars? Who gets to decide who owns the next solar system over, the next galaxy over, etc.?
Well, it's not so much. It's not so much about owning as about replicating what we find precious here on Earth elsewhere, so that it will not go away when there will be a single point catastrophe on Earth. That I think is the most important goal. And that's basically what biology tries to fulfill by having, the DNA transferred from generation to generation, preserving the important elements that biology wants to preserve. But we can do the same thing for our intellectual assets, for our aspirations, and just try to go elsewhere so that we will not lose everything as a result of something bad happening here on Earth. But in terms of convincing people to unite, I think it's the same power that religion has, in the sense that once people have awe, once you realize something much more powerful than you are, and it's not a concept, it's not a philosophical idea, but it's something real. that you see, okay? And maybe you don't even fully understand it, but it does things that bring awe to your existence, then everyone, I think, will change their behavior. And it's not so much to do with who claims ownership or who is more powerful to convince the rest of the people of something. It has nothing to do with the traditional way that we approached human history. Our traditional way was about zero-sum games, situations where there are limited resources, limited, land, and so people fought, and the win of one person was the loss of another because it's a zero-sum game. That was traditionally the case. But if you think about science, science is not a zero-sum game. It's actually an infinite-sum game, in the sense that if we gain new knowledge, everyone benefits. Everyone that has that knowledge. That's why science should be shared by all humans. And the same is true about scientific knowledge on our cosmic neighborhood. If we gain some knowledge about what other extraterrestrial civilizations have accomplished, we will all benefit from it. So we should work together. So science brings a completely new element to our existence, which is very different than our tradition of fighting over limited resources, zero-sum games. It brings the concept of an infinite-sum game where, if we all open ourselves to new knowledge, we will all benefit because it's unlimited. We can get much better as we move on. The other hope that I have is, that AI systems will not inherit our flows. For example, we are starting to use AI systems now in science. And just imagine an AI system digesting all the data about Oumuamua and saying, well, if I compare it to known comets, it doesn't look like a comet. That's what the AI system will say. It doesn't have the ego of an expert that was engaged for decades working on comets made of water ice on their surface, and therefore it would not have this tendency of saying, oh, there is nothing new under the sun. My expertise is protected. Everything we knew from the past applies to the future. Therefore, I'm still the ultimate authority on this subject. Okay, that's the approach of an expert in academia. And that's not a good approach. That's not an approach that is driven by curiosity. And I can imagine an AI system analyzing the data and saying, sorry, it's not a comet based on everything we know. So it will be as innocent as I'm trying to be, basically practicing common sense rather than promoting your ego, showing off your expertise, and trying to garner likes on social media. That may not be the motivation of the AI system. I hope that helps us in doing science. And in that way, we can bring humanity to a better place, where instead of bragging, showing off, and trying to garner honors, we will engage in substance. And what I mean by substance is not talking about the simulation, not talking about ourselves as being very smart and the only ones in the universe, but rather just collecting evidence and looking around to see what nature has to offer us. Because the imagination of nature is very often more than our own imagination, and we can learn a lot from it.
Yeah, Avi, man, there's so many more questions that I'm keen to ask, but we're going to have to wrap up shortly. You've mentioned AI a bunch of times. I'm just wondering, how are you utilizing artificial intelligence at the moment? What are some of your hopes for artificial intelligence in the future, and how do we keep AI from inheriting our flaws? You mentioned about creating something in our image. We are deeply flawed in many of the ways that we've just identified over the last hour or so. How do we prevent AI from doing that in the future, and how are you finding AI helpful even right now?
Well, the way to prevent that is not to make them exactly in our image. In other words, to avoid our flaws. And we can do that because we are constructing them. So, just like I want my daughters to have a better future than I had in the past. And so I'm giving them a sense of reality which is far better than I experienced this throughout my life. So it's just a question of goodwill, and it offers us this opportunity of having those technological kids behaving in ways that are far better than humans. And it's under our control at the moment. Eventually, those AI systems will establish their own community. There is this, the philosopher Buber, who distinguished the interactions of humans with the environment as I, though, that's the interaction of myself with another human, or myself with objects, I, it. He lived a century before AI was created, and so today we have to add AI interaction, the interaction between human and the machine, but there would be a next phase, which is AI, because once AI interacts with AI, they would establish their own community. They can evolve very quickly, uninfluenced by humans, but more influenced by their own community, so to speak. And, there is, of course, the concern that they would bring big risks to the existence of humanity, but, that has to be mitigated, of course. And with respect to our future, one way to get a glimpse at what it might look like is to find what happened to other civilizations, statistically speaking, by exploring the sky.
All right. I just one thought on the trying to edit out or code out our flaws still assumes that somebody knows or someone is deciding what is a flaw and what we want to exclude. So we're still privileging something in the code, and we need to, I'm just wondering, because what I hear from you over and over again is the value of curiosity and humility. And so I'm wondering, how do we approach this humbly and say, isn't the humble thing to say, well, we don't know what is a vice. And in our culture, we might think this is a flaw. And in this other culture, they might hold it up as something that's particularly worthwhile. What I'm hearing you say is, if we can go and find other civilizations that are more advanced than us, we can actually learn from their mistakes, failures, and successes, and try to bring that back into us. Or am I missing a part of humility here?
Right. So here is the way I think of it. I'm an optimist. So I interpret natural selection, the Darwinian process of survival of the fittest. Also, in the interstellar context, I interpret that as, the species that will be the fittest is the one that will be the longest lived. Okay, and what does it mean in interstellar space? I mean, you, in principle, you can imagine confrontations. Civilizations that are aggressive and they are engaged in wars and so forth. I think those are less likely to survive long because of the friction that they encounter with others when they try to be aggressive. And in my view, a more peace-seeking, exploring scientific civilization has a better chance of surviving longer because it will not get into confrontations. It will adapt to the reality that it inherits in a softer way. And rather than appealing to who decides what is the best approach, I would appeal to natural selection. And natural selection would basically select the fittest. And if you want to make a shortcut and ask what is the fittest in the big scheme of things, in my mind, it's that species that manages to survive the longest throughout the history of the universe. And of course, we may continue to stay on the surface of this rock and read newspapers every day talking about wars and talking about conflicts and investing all our resources in our pleasures without taking care of our planet. And then within a few centuries, we'll just die out of self-inflicted wounds. That's a possible scenario. Just that a technological civilization like ours, which is not intelligent enough, does not survive very long. But that proves my point that, that someone else, I mean, if you are imagining civilizations exploring all possibilities, those that are engaged in the right principles will be the ones to survive, and they are the ones to be rewarded. So rather than having someone tell us, you should do this or that, I think natural selection will do the job. And frankly, what I really want is for us to survive the longest. And in order to accomplish that, we should act as responsible scientists, that we should explore our environment with open eyes. We should not just be motivated by our ego to get honors and awards in academia. That's not really what we are about. It's all the approach of a wandering kid that would like to get better, because in the class of intelligent civilizations out there in the Milky Way galaxy, we may not be the smartest student. I often tell my students at Harvard University on the first day of class, I say, half of you are below the median. And that's just a fact, because statistically speaking, the median in any class separates half of the class from the other half. And of course, students at Harvard all want to be at the top, and they find it difficult to accept. But if I were to bet, I would say our civilization is currently not, it's somewhere in the middle of intelligent civilizations that develop technologies. It's not really near the top. And so to be better, we should learn from the smartest students in our class.
Avi, there are so many more things I'd love to chat with you about. We might have to do that another time. Thank you so much for joining us today. You've got a new book coming out later this year, Interstellar. How else can people find you online or hear more from you?
So I have a website at Harvard University, but if you want to follow on developments, I post an essay in Medium every couple of days on different topics, from interstellar space to AI to philosophy to society to astronomy. And so if you are curious about these topics, just check me out, Avi Loeb at medium.com.
Thanks, Avi. Really appreciate your time.
My pleasure.
Thanks for joining us for today's episode of the Off-Chain Podcast. Hope you enjoyed this episode with our guest, Dr. Avi Loeb. Man, really phenomenal thinking about the stars and intergalactic objects and what the future of humanity might look like. As always, like, subscribe, or even better yet, spread the word. Share this episode with a friend. Help us spread the word about the Off-Chain Podcast. Join us again next time. We're actually going to have a part 2 of our chat with Dr. Avi Loeb. As you may recall, in the episode today, he spoke about an upcoming expedition he was going to take to somewhere in the Pacific, just off the islands of Fiji, and he's actually been on that journey now and returned. And so we're going to find out what he found. Did he find what he was looking for? How does it help confirm or challenge his hypothesis? That's going to be a really interesting chat. So join us next time on the Off-Chain Podcast. Till then, take care.